locating percentiles under the normal curve. So before we start, let me just have a quick recap of the concept of percentile. So for any measurement or measurements arranged in ascending or descending order, percentile is a point in the distribution that such that a given number of cases is below it. So for example, in a statistics test, for example, you got a score which is 85, and you want to know how you fared in comparison with the rest of the class. If your teacher tells you that you scored at the 95th percentile, so it means that 95% of the grades were lower than yours and 5% were higher. So that's the concept of percentile. So let's proceed to locating percentiles under the normal curve. So we have this sample exercise taken from the book Statistics and Probability by Belicina, Bacay, and Mateo. So find the 95th percentile of a normal curve. And by definition of 95th percentile means locating an area before or below the point. And we want to know what the z value is at this point. So we have 5 steps here. So the first step is for us to illustrate the normal curve. So this is the first step. Illustrate the normal curve, and let me just insert the normal curve image. So applying the concept of percentile, we will arrange the values in the normal curve in ascending order. So we have here, so the first percentile is going to be at the leftmost part of the distribution or the normal curve, and the 50th percentile corresponds to the mean, okay, and or the center, and the 99th percentile will be at the rightmost part. So this is now the working normal curve that we will have for this sample exercise. Let's proceed to step number 2, which is to express the percentile into percent and then into probability. So here, let me just move this a little here. It's bigger. So express the 95th percentile as percent. So this is going to be 95%, which is equal to, then as probability, 0.9500. Okay? Then let's proceed to step 3, which is to expand or split the probability into 2. And the characteristics of each should reflect the areas found in the normal curve. So let me just put it here and move it a little up. So in this case, this is what we're going to do. So 0.9500 is equal to 0.5000 plus 0.4500. Again, we have to do this so that we can locate the z-score or z-value that corresponds to our 95th percentile, which is found above the mean. If you're going to look at the illustration that we have on the first step, so basically 95th percentile is above the mean, somewhere here. So somewhere here. Just somewhere here. So question mark, we do not know yet. And let's proceed to the fourth step, which is here is to locate the area or areas in the normal curve. So we're going to create another normal curve here, just a duplicate of what we had in the first step, or on the first step. So here, so insert image again, the normal curve. Then from here, since we already have expanded the probability 0.9500 to 0.5000 plus 0.4500, then we have to identify this time the where these areas are. So we have, again, no, P1 or first percentile, we have the 50th percentile here, and we have the 99th percentile. So this area, we have two areas. So the first area corresponds to the what you see entirely at the left side of the normal curve. So this is our 0.5000. Okay, that's our area, the entire left side of the normal curve. Now, so this is okay, put an arrow. So now we have to find the missing area of 0.4500 in the normal curve. So it's somewhere, as I said earlier, above the mean, so somewhere there, but we do not know yet. Okay, we have to still determine or to check where is this area. Now, the next step here is for us to identify determine. We have to determine the z-score that corresponds to the area that we are looking for. Okay, so let me just move this here and up so that you can see. Make some adjustments. So determine the z-score that corresponds to the area that we're looking for. And the rule of thumb here is we have to find the area in the z-table closest to the area that we are looking for. Now, we have to use the z-table in this case. So again, you have to remember that we're looking for the z-score that corresponds to the area 0.4500. Okay, so here, this is just going to put it here, and remember again, we're trying to look for this area 0.4500. Okay, question mark, we do not know yet. So in the z-table, we actually have two areas. So again, in the z-table, we actually have two areas closest to the area 0.4500, and these are 0.4495, which has a z-score of 1.64. So here, let me just make this a little bigger. Okay, there you go. So 1.64 here, this one. Okay, sorry, let me just, okay, there you go. And the other one is 0.4505, which has a z-score of 1.65. So this, okay, that area. Now, both areas have the same distance from 0.4500, which is 0.005. So in this case, we have to find the z value by interpolation because they have the same distance or difference. So we cannot choose like either 1.64 or 1.65. So in this case, we have to solve it by interpolation. So meaning we have to get the average. We have to get the average of the z-scores here. We have z is equal to 1.64 plus 1.65 all over 2. So now our z-score is going to be equal to 1.645. Okay, so this is now the z-score that represents 0.4500. Okay, or what we call our 95th percentile, or our 95th percentile. Okay, that's it. This is our final answer already. Okay, this is our final answer. That's our final answer. Z is equal to 1.645. Thank you.